Hi students, welcome back. Let's continue with the subject compiler design. The next topic was the implementation of lexical analyzer. Okay, so before going to know about the implementation of lexical analyzer, just recall the structure of compiler. So why I am just recalling the structure of compiler means if you just recall the structure of compiler, you can know at what stage you are discussing. Means whatever the source language you are taking, that is a high level language, that high level language is going to be converted into different phases. Okay, so lexical analyzer will be it's a one phase, means it translating the high level language program into lexical analyzer. So that's lexical is going to be converted into syntax format, okay, which generates a parse tree. And next is a semantic analysis. Next it finally convert into the code generator. So with the help of the code generator you will get the intermediate code. So that intermediate code will give a code optimization, and that code optimization is with the help of the target code generator. This code optimization will give the final target language. Okay, that target language which is in an assembly level language. So the high level language is going to be converted into assembly level language with the help of this compiler. So before discussing about each and every phase, let's just recall the structure of compiler so that you can aware of at what stage you are in. Okay, means is that high level language is already converted. If you want to discuss with the semantics, first that high level language should be converted into lexical, and lexical should convert it into syntax. Next it should be in semantics, like that. Okay. So these lexical analyzers, syntax analyzers, semantic and intermediate code generation, these are all comes under the front end. These are the front end of the compiler. And whereas the code optimization and the target code generator is the back end of the compiler. Just remember this. These four comes under this front end and these two comes under the back end. Okay. So now let's discuss about the lexical analyzer. That is the first phase in the compiler. Lexical analyzer. Okay, so the lexical analyzer is the first phase of the compiler, whatever we see now. The main task of lexical analyzer, what is the main task of lexical analyzer? It is used to read the stream of characters. So first let me tell you, the lexical analyzer is also called as a scanner. Okay, so this scanner is used to read, scanning, you know that meaning. Okay, it just reads the data. So the lexical analyzer reads a stream of characters, one by one. Just note that it's read a stream of characters one by one as input, okay, and produce a sequence of tokens. So it's just read the input and produce a sequence of tokens that the parser syntax analysis uses for syntax. So which is producing a sequence of tokens, and it will helpful to the syntax analyzer. Okay, so this lexical analyzer, it just takes the input, it reads the stream of characters as input, means whatever the high level language you are written. So each statement or each character it will be read, and it produces a sequence of tokens for each character, and that tokens will be represented, sent to the syntax analyzer to parse the tree. So let me show you the picture. So here is an input, let's take which is in a high level language. So that program is read character by character, read character one at a time, and sent into the lexical analyzer. So what this lexical analyzer will do, this lexical analyzer reads characters and sends produces output as a tokens. Okay, I'll explain clearly what is this token and everything, and then next. Okay, so first it reads the character, and this lexical analyzer produces a tokens, and the tokens will be the input for the parser. Okay, so once it get one token, it asks for the another token. Get token next. Get next token. Okay, it is asking to get the next token from the lexical analyzer. Now, then lexical analyzer take from the input. It is asking to push back character. So this lexical analyzer and the parser will have a symbol table support. Symbol table. So this is actually the process of the lexical analysis. This we already discussed in the previous video. Just I'm recalling that. So if you just recall about the lexical analyzer, then you can implement the lexical analyzer by using the tools. Okay. So let me just show you with the help of the source code how it is going to be generated. It's a simple. Let's take a source code as it's just an input. Let's take A is equal to B plus C into D. So this is a source input which is written in high level language. Okay. So now the lexical analyzer, what it is doing, it converts into sequence of tokens. So it's take one character by character at a time. Okay. And produces a tokens. A tokens in the form of ID1, ID2 plus ID3 into ID4. Okay, so all these characters are converted into tokens. These tokens will send to the syntax analysis. Syntax analyzer. Okay, so what the syntax analyzer will do? It produces a syntax tree. Syntax tree will be generated. Let's take ID1 and this is produce plus ID2 star, here the star. The star will generate ID3 and ID4. Okay, so this is syntax analyzer. So this comes complete and this is all front end. So in the back end, it is going to be generated as with the help of the code generator. You will get the final target language. You will get the final target language. So what is the target language? It is in the form of generated code assembly language. Load ID3, mul ID4, add ID2 and finally store ID1. So this is actually the process. I hope you understand what exactly the lexical analyzer will doing by taking this example. Our main aim is whatever the input we are taken, that is a high level language, that the compiler is going to, this completely is a compiler. Okay, with the help of the different phases in the compiler is going to convert that high level language into assembly level language. So here in this we are discussing the first phase. The first phase, what it is doing, it is just taking the input from the source code. Okay, just take the source code and convert that each character into a series of tokens. Okay, so with the help of the token, so that the compiler will understand what the high level language was. Okay, what is that input? Because it doesn't read the alphabets. Okay, the compiler doesn't read the alphabets. So just the lexical analyzer is going to be convert that into a tokens. Okay, so this is just an introduction part. Now let me explain you the implementation part. So how you are going to implement the lexical analyzer? Implementation of lexical analyzer. So the lexical analyzer can be implemented by using different tools. Okay, it can be implemented by using different tools. So before going to explain about each and every tool, with the help of the tool, how the lexical analyzer and the parser is implementing, let me just take a simple example how the internal process, how the lexical analyzer is going to remove, means how it is going to be converted into tokens. So that is the implementation of lexical analyzer. It's just taking the source code and converting into tokens. How it is doing? Let's see that. Okay, so the lexical analyzer must be able to do three things. What are the three things? The first one is it is removing all white spaces and comments. Removes all white spaces and comments in the program. So whatever the input high level language code we are taken, that will, in that code, it's the lexical analyzer is going to be first removing all white spaces and comments, whatever that is present. And the second point, the second thing it is doing is identifying tokens within a string. Identify tokens. So I'll explain what token is also. So first removing the spaces and the comments. Next in that string it is identifying what are the tokens. And the third one is it return the lexeme of a found token. Return lexeme. This lexeme is also, I'll explain, don't be confused. Just see what are the three main things that the lexical analyzer is doing, how it is going to be implemented. First removing white spaces, and next identifying the tokens. After identifying the tokens, it return the lexemes, what are the lexemes that are present for each token, as well as the line number it was found on. So these are the main three things that the lexical analyzer is doing. Okay, so now let me explain you what is this tokens and the lexemes. So if you understand what exactly the tokens and the lexemes, then you will know how the source code is converting into tokens. So actually the tokens is nothing but it describes the category of input strings. It describes the category of input string. What is this described category of input string? I think you didn't understand. A token is nothing but you can call it as an identifier or a keyword or punctuation symbols. Those are all comes under these tokens. Identifier, keywords, even punctuations like semicolon, hyphen. So those are all comes under the tokens. We just call those names as a tokens. Just it is name. Then what about the lexeme? What about the lexeme? Lexeme is nothing but a sequence of characters. It's just a sequence of characters in the source code. In the source code. So here we in the previous example we take A is equal to B plus C into D, like that. So here the sequence of characters in the source code that are matched with the pattern of tokens, So that is a lexeme. Lexeme is a sequence of characters in the source codes that are matched with pattern of tokens. Okay, so pattern is nothing but a set of rules that describes the token. So here let me take one example so that you'll understand what exactly these lexemes and tokens are, everything. Let me take an example. Let's take A is equal to B plus C. So this is a source code. So here, what are the tokens? Tokens, I said, tokens are nothing but it describes in category of input string. So here this is an input string. So what is it? What it describing? So here A is equal to B plus C is there and semicolon. Let's take. So tokens is nothing but a keyword or punctuations or identifiers. So it's just describing the category of input string. So what are the categories of this input string? This input string consisting of identifiers. You just write the category only the category. Identifiers, that is A, B, C or identifiers. And it is having the operators. What are the operators? Is equal to and the plus. Two operators are there. And it is having the punctuations. What is the punctuations here? The semicolon is the punctuation. So that is a token. A token is nothing but identifiers A, B, C and the operators is equal to plus and the punctuation semicolon. Then what about the lexemes here? What lexemes tell? The lexemes is nothing but the sequence of characters in the source code. So this is a source code. The sequence of characters in the source code that are matched with the pattern of tokens. That are matched with the pattern of tokens. Okay. So what is that? Here, what are the items that are matched with the pattern of tokens? Items are A, B, C plus is equal to semicolon. These are the lexemes. So in the given source code, the tokens are nothing but the names which describes the category of input string, whereas the lexemes is the sequence of characters in the source code that are matched with the pattern of tokens. So lexemes are nothing but you just write what are the terms that are used in that source code. Okay, so this is about the tokens and lexemes, and patterns is nothing but the set of rules that are going to be followed. Rules are nothing but if identifier means the identifier should be start with the alphabet or underscore symbol like that. Okay, the plus is only used for addition, the into is only used for the multiplication, means it's just following the set of rules. So let me take a simple example of how to implement the lexical analyzer. Okay, the program I am taking to implement the lexical analyzer. Our main concept here is I want to implement the lexical analyzer. So I am taking the source code int maximum int a comma int b. So if a greater than b, I have to return a, else I have to return b. Return b. So from this, so this is a source code. This is a source code. What the lexical analyzer will do? The lexical analyzer is going to be convert the source code into series of tokens. So what this program is converted into tokens and the lexemes. So what are the tokens here? The tokens and the lexemes. Let's see what are the tokens here. The tokens are keyword. So what is the keyword here? Int. So that is a lexeme. Keyword is, this is a keyword, and the lexeme is which matches with the pattern of token. That is the int is a lexeme. So next is a max. Max is nothing but identifier. Max. Next, this is the operator. The keyword is the operator and the lexeme is left parenthesis. Next, int. Int is a keyword. Keyword is a token and integer is a lexeme. And A is an identifier. Okay, you just write A here. So like that you have to find this complete program is converted into tokens and the lexemes. So this is how you are going to implement the lexical analyzer. So in the next video, I'll explain how to implement the lexical analyzer and the parser by using the tools. So with the help of the automated tools, the compiler can easily convert the source language into target language. Thank you.